Hello friends, today we are going to start with the operators in Java. It is the fourth chapter. Types of operators are arithmetic operators, bitwise operators, relational operators, and logical operators. Arithmetic operators that perform arithmetic operations on operands like addition, subtraction, multiplication, and division. These are the basic arithmetic operators. Modulus operator, it is just a separate special kind of operator that returns the remainder of division operation. So class modulus example is given here. Here I have declared one integer variable x is equal to 42, y is equal to 42.25. So when I x mod 10, it will return me 2 because remainder of 42 divided by 10 is 2. And when I do y mod 10, it will give me 2.25 because resultant output is saved in a double variable and if it does not eliminate fractional component. Then arithmetic assignment operators, plus is equal to, minus is equal to, multiplication is equal to, and division is equal to. The combination of these four are called as arithmetic assignment operators. Arithmetic operation is done first, then assignment will take place. A is equal to A plus 4 can be rewritten as A plus is equal to 4. T is equal to T modulus 2 can be rewritten as T modulus is equal to 2. So what is the general syntax of this arithmetic assignment operator? It is variable is equal to variable operation. Expression can be rewritten as variable operator is equal to expression. Increment and decrement operation. X is equal to x plus 1, we can rewrite it as x plus plus, and x is equal to x minus 1, we can rewrite it as x minus minus. But the sequence of where we are writing the increment and decrement plays very important role in Java. For example, if we are writing plus plus x, then increment will take place and then assignment to y will happen in this case, and the last y is equal to plus plus x can be evaluated as x plus 1, x is equal to x plus 1. So first x will be incremented and then y will be assigned new value, that is 43 will be assigned to y. Byte representation to integer representation. So binary of 42 is written as 00101010. Each position is power of 2. So to power of each position and addition, doing addition, how we will write it as? The first position is from right to left. The first one is 1. Here the last is first index from right to left is 0. Then second index is 1. So 2 raised to 1 is calculated here, plus the third position 2 raised to 3 plus 2 raised to 5. So addition is performed over here, and after addition 42 is taken out. Every position is taken out, which is only 1 is there. So 0, anything raised to 0 raised to anything will return us nothing. So only the positions which have 1, binary representation 1, have taken over here. Then bitwise operators. There are bitwise logical operators. We will see bitwise NOT will invert all the bit of its operands. 42 number is byte is 00101010, and when I will invert it, it will become 11010101. Then bitwise AND produces bit 1 if both the operands are 1, 0 otherwise. If both of the operands, when we are performing AND operation, when both of the operands and 1, then only the output is 1, otherwise it is 0. Like 0 and 1, it is 0 because one of the operands is 0. Here 2 operands are 1, so output is 1. So 42, binary representation of 42 bitwise and binary representation of 15 will give me binary representation of value 10. Then bitwise or, if either of bits is 1, output is 1, otherwise it is 0. Only 1, either of bits is 1, maybe 1 or 2. If both of the operands are 1, then also it will return me 1, or either one of the operand is 1, it will return me 1. So 0, 1 is also returning me 1, 1, 1 is also returning me 1. So binary representation of 42 bitwise or binary representation of 15 will return me 0, 0, 1, 0, 1, 1, 1, 1. That is the binary representation of 47. Then bitwise XOR. If exactly one operand is 1, then result is 1, otherwise it is 0. So here only 1, exactly one operand is 1, then only it is returning me 1. So binary representation of 42 bitwise XOR binary representation of 15 will give me binary representation of 37. That is 0, 0, 1, 0, 0, 1, 0, 1. Now we will move to the relational operators. Equal to. These all relational operators are used in if block, if else block, and while condition checking in for loop. So these are 6 operators: is equal to. They are used for equal to, checking equals of 2 of the operand, not equal to, or one of the operand is not equal to another operand, greater than if first operand is greater than another operand, if first operand is less than second operand, if first operand is less than greater than equal to second operand, and if first operand is less than or equal to second operand. When performing the programs one by one, you will understand the uses of these operators. Here integer a is equal to 4 I have taken, and b is equal to 1. Boolean c is equal to a less than b. So what is a less than b? It is checking if a is less than b, true or false. So resultant output is saved in Boolean variable c. Integer done, if not done, if done. So if not done is valid in C++, because integer checking, that is 0 and 1, is in C++. 0 is equal to false and 1 is equal to true. But in Java, when you are using checking for Boolean output, in if or in for or in any block that you are using, if it is true and false, then only it is valid. 0 and 1 will not be checked for true and false purposes like in C++. In Java, true or false are non-numeric values which do not relate to 0 or non-zero. So there is no relationship between 0 and true or non-zero and false in Java. So if done is equal to 0, it is valid in Java, and done is not equal to 0 is also valid in Java. So you have to check it using equal to and not equal to relational operator. Okay. Directly you can pass Boolean variable here like C, if not C, because C is a Boolean variable which directly relates to true and false. But you cannot use integer variable in if block, else block, or while loop, do while loop, or for loop. Okay. Then Boolean logical operators. These are some Boolean logical operators: logical and, logical or, logical not, short circuit or, short circuit and, logical unary not, and assignment or assignment, X or assignment, equal to and not equal to. So these logical operators are used for checking multiple conditions at the same time in the same line. So when you are using big if blocks or big while loops, where you have to check multiple conditions at the same time to perform one particular operation, you have to use these Boolean logical operators. Here is the chart. You can write it down if you need. So if A is false, B is false, A or B will give me false, A and B will give me false, or A XOR B will give me false, and not A will give me true. Logical not. Then true, A is true, B is false. So A logical or B will give me true, A logical and B will give me false, A logical not will give me true, and not A will give me false. If A is false, B is true, A logical or B will give me true, A logical and B will give me false, A logical not B will give me true, and not A will give me true. If A is true and B is also true, what will be the result? A logical or will give me true, A logical and B will give me true, A logical not B will give me false, and not A will give me false. And lastly, the last operator we are going to see, that is ternary operation. Ternary operator, that is very much simple operation. Simple operator, when if you want to perform operation, like if particular condition is true, then perform this type of operation, and if particular condition is same condition is false, then you have to perform this type of operation. So like if particular condition is true, then perform this, else this. So this can be written in one line. If expression is evaluating to some expression of some value like true and false, you can use this ternary operator. For example, ratio expression 1 question mark expression 2 colon expression 3. For example, ratio is equal to denominator is equal to 0. If denominator is equal to 0, if it is true, question mark. If it is true, it will give me 0. And after colon, if it is false, it will give me num divided by denominator. So ratio will be evaluated depending upon this ternary operator expression. And this is the operator precedence in Java. The highest precedence is given to opening and closing parenthesis, opening and closing square bracket, and dot signs. Then increment, decrement, and reverse operation. Then multiplication, division, and percentage, addition, subtraction, right shift, unsigned right shift, left shift, greater than equal to, less than equal to, is equal to, is not equal to, and, or, not, and, logical, and. So in this way, these operators will be evaluated when you are using a big expression. In that, depending upon this chart, you will get to know how the Java will evaluate expression one by one. So this way, we have completed using parenthesis. Parenthesis gives higher precedence to operators inside them. For example, A right shift B plus 3 is different than A right shift B plus 3. So when you are writing anything inside a parenthesis, it will give you highest precedence to anything written inside the parenthesis. So this way we have completed operators in Java. In the next session, we will see control blocks like if, else, while, do while, etc. So meet you in the next session. Thank you so much.